Okay, so 13. Yes, the beginning of your note. So 13, that's fantastic. It'll help reinforce it, it'll make it better. So we have x plus 2, then 3x cubed plus 9x squared. Plus 8x plus 4. So first thing you always want to look for is to make sure that you have all the parts, right? Because you have to go x cubed, x squared, x in the number, which in this problem it does. If we're missing the x squared term, you have to put in the 0x squared. Got to have a placeholder, both with long division and synthetic division. Griffin?
Do you need the number at the end?
Yeah. Yes.
You don't put 0 if there wasn't a plus.
Yeah. That's weird because I was just thinking, like, I've never seen a problem in all the years of teaching Algebra 2 without a number at the end. But yeah, you would still have to put a 0 though. Good question. Yep. Yeah. Well, if it starts at x squared, then you wouldn't add another one in front. Yeah. Right. You'd have to put a 0 x squared. Yeah. Yeah. Standard form, in order. Yeah, really important. Both synthetic division and long division got to be in standard form, otherwise it doesn't work. So we have two terms outside, we start two terms in. I know this is going to be an x squared because of this x squared. This variable exponent combo is always going to match. Always, 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 every single time. The only thing that could change is the number in front. Yep. So what times x equals 3x cubed? So we need 3x squared. Okay? So we're going to put a 3 in front of that. Andrew?
So why would it matter where you start on the top? Because there are two terms outside. If you start over the two terms.
Yeah, I mean, it matters because I know once I write the term up here that I'm done. And if I have a number left over at the bottom, that's my remainder. So it just helps you stay organized.
So will you take points?
No, I mean, I would do it this way because it's more organized. So now we do 3 times 3x squared times 2, which is positive 6x squared. 3x squared times x, which is 3x cubed. So we're going to put in parentheses. So where these two terms come from, 3x squared times 2 is positive 6x squared. 3x squared times x is 3x cubed.
You're always going to do the second one first.
Inside, then outside. Inside first, then outside, when you multiply from the top. I always, every year, get some kid who's super cocky, doesn't want to do it, just wants to subtract. Every single year, they've always got it wrong. So do you have to? No. No, you don't have to. But I would recommend it. Just makes more sense. Makes it make more sense because I'm thinking about distributing the negative into the parentheses. So switch all my signs. 9x squared minus 6x squared is 3x squared. Then I'm bringing down my 8x. And I'm saying what times x equals 3x squared.
Are the 3x cubed and the 3x always cancel?
Yes, the first term here is always going to cancel. So we're going to put a 3x up top.
No, it doesn't go to the top.
Yep, exactly. Good. So we do 3x times 2, which is plus 6x. 3x times x, which is 3x squared. Put in parentheses. Now we're going to switch the signs. So we have 8x minus 6x, which is 2x. Right? First term always cancels. Bring my 4 down. plus 4. Now we're thinking what times x equals 2x, right? This term always comes from the first, right? 3x cubed, 3x cubed, 3x squared, and then 2x, 2x. Right? This just kind of helps you stay organized with that. So now, what times x is 2x? 2. So we have a 2 up here. So 2 times 2 is 4. And 2 times x is 2x. Parentheses, switch the sign, and we get 0. So no remainder on this one. So your answer then is what's up here. The work shown is how I give you partial credit, right? Even if you mess up somewhere along the way, I can still give you partial credit because I can tell where you messed up. Griffin?
So if you have the same like numbers at the bottom, you don't really have to subtract because they just cancel out. Just 2x plus 4 and 2x plus 4, they just cancel out.
Yeah, because when you switch the signs, they're automatically going to cancel. Yeah. Yep.
Once we get the equation on the top, should we rewrite it or just leave it?
No, you can leave it right up top. Totally fine. All right. So what was the next one? 14. 14 is x minus 1 outside, and inside we have 9x squared minus 21x minus 20. So we're starting at x squared, which means the problem's going to be shorter. That's all it means.
And that would have been
Right. So you don't have to add it. It just starts at x squared. So I've got 2 terms outside. I'm going to start 2 terms in. This variable always matches the one up top. So I'm going to say what times x equals 9x squared. 9x. So all I have to do is add the 9 in front of that x. So I have 9x times negative 1, which is negative 9x. Then I have 9x times x, which is 9x squared. Put it in parentheses, switch the sign. And then we have 21 plus 9, 12x here. So 12x, bring my negative 20 down. Thank you, negative 12x. And then bring my, again, negative 20 here. Okay, so now I'm saying what times x equals negative 12x. So negative 12. So if this little side thing helps you, do it. If it doesn't and you don't need to, then don't do it. No biggie. So we have negative 12 here. Then we do negative 12 times negative 1, which is positive 12. And negative 12 times negative x, which is minus 12x. Put in parentheses, switch the sign. So what's my remainder? Negative 33. So realize if you struggle with negatives, get in your calculator, don't make the mistake. I see all the time you guys making little mistakes like that because you don't put it in your calculator. So our remainder would be negative 32 over x minus 1. Okay, so synthetic division is way easier to do than this. For questions first, Griffin.
Do you have to do the x minus 1 or is it okay if you just
You got to do the x minus 1. It'd be like half point off. Yeah. Why not? You could have any remainder. Yeah, doesn't matter. Yep.
Are you going to come off with the definite over the
Yep, half point. Okay, synthetic division, way easier than this. So I had a kid ask second period after they saw synthetic division and saw how much easier it was. Can I do the problem with synthetic division to help me do the problem with long division? Absolutely. I just want to make it very clear, you have to be able to demonstrate both methods. On your test, you have one problem with long division, you have one problem with synthetic division. Okay, you have to be able to show me both methods. But if synthetic helps you to get the long division, do it. Sure. Why not? Here's how synthetic division works. So to try, what? Yeah. Synthetic division, way easier. Way easier. So I'm going to write the directions down so you can see what the directions look like. Two different kinds of directions. Well, this is not too hard. It says divide using synthetic division, so I'm not going to write that down. That's easy. Alright, so let's try to find one that works. Okay, so we're going to do x cubed minus 3x squared minus 5x minus 25 divided by x minus 5. Okay, so when you do synthetic division, we want to take the binomial here, set it equal to 0, so we get x equals 5. So, phone away? Yeah. So we're going to put 5. I call this the elbow right here. We're going to put 5 in the elbow. So I have to take this binomial, set it equal to 0, and that's what goes in the elbow. Then I take each coefficient, right? So I have a 1 here, negative 3 here, negative 5 here, negative 25. And I write those, no variables, just the number form. So 1, negative 3, negative 5, and negative 25. I write it just like that. Next, I'm intentionally leaving space below here, okay? Because I'm going to be writing numbers up here. Again, this would be one where it's good to just listen to the process without questions. We'll do 2 of them. Then you can ask questions on the third one, just so you get that process down. Very first step, I bring down the first term, which is 1. So down here, I'm going to be multiplying. And in this row, with these first 2 rows, I'm going to either add or subtract depending what the sign is. So when I say multiply, here's what I mean. I do 5 times 1, and I put the results up here. So 5 times 1 is 5. A lot of times you guys get hung up on, am I adding or subtracting here? Just do what the signs tell you to do. Don't think about adding and subtracting. All I think about here is negative 3 plus 5. It helps you to put a plus here. That's fine. Negative 3 plus 5 is what? 2. Okay, now I'm at where I'm going to multiply down here, right? So 5 times 2, I put the result above the line, is 10. It helps you to put positive 10 for positive 10. So now we do negative 5 plus 10, which is 5. Now I'm going 5 times 5, which is 25. So I kind of do reverse elbow here, and this is what your remainder is going to be. So what's my remainder here? 0. So this little reverse elbow thing is where, make it longer, your remainder is found. Okay, so we're dividing x cubed by x, right? X cubed, I know a whole bunch of other stuff, by x. So what's this going to be down here? X squared. When we divide x cubed by x, we're going to start with x squared plus 2x plus 5. That is my answer. Way easier, right? So this chapter keeps building, right? So just so you have a sense of where we're heading, we'll have x to the fourth up here. Some problems you have to do synthetic twice. Some problems you have to factor this. And then sometimes it won't factor, like this one doesn't factor, and you have to do quadratic formula. Okay? For now, we're just doing the synthetic part. Okay, that's it, nothing more. Emma?
How did you get x squared?
Because we're doing x cubed divided by x.
Oh.
It's got to be x. It's got to start at x squared down here. All right, let's do another example. Yep. We tried to, well, we did. We cut this chapter in half because this whole chapter as a test would just be wicked. So dividing it in half to make it easier on you guys. I know you don't think we think that way, but we actually do. All right, let's do. Okay, so we'll have 3x squared plus 17, or sorry, 3x cubed. 3x cubed plus 17x squared plus 21x minus 9 divided by x plus 3. So first thing I do is I set this binomial equal to 0, so x equals what? -3. Really common error juniors make is they forget to do that part. Because if you put +3 in the elbow for synthetic, it all goes wrong. So you got to be careful with your signs here. I will tell you that when you do synthetic or long division, if you're going to have a remainder or not. So if you end up with a remainder after doing synthetic and I tell you you're not going to, then go back and check your math. You made a mistake. So what goes up here? 3, 17, 21, -9. So you can see why doing synthetic, if you have a long division problem without a remainder anyway, or even with a remainder, doing synthetic would help you to get the correct answer doing long division. So you can do that, but you just have to be able to show me the long division. First step, important, bring that 3 down. -3 times 3, -9. 17 minus 9, 8. -3 times 8, -24. 21 minus 24, -3. -3 times -3, +9. Remainder, 0. So again, we started at x cubed. We're dividing by x, so my answer starts with x squared. X squared plus 8x minus 3. That is your answer. That's all you got to do. Yeah.
Can you use this problem to check your answers for the long division?
Yes, you can. Okay, so next, it's just worded in a slightly different way. You're still going to do synthetic division. Let me show you what it looks like. So I'm going to write some directions so you can see those directions. So the directions will say use synthetic division and the remainder theorem. If you have to know what these directions mean, synthetic division, So all the remainder theorem says is that if we divide a polynomial by p, and I have a number in here, the result is going to be the remainder. So essentially it doesn't really mean much. Okay? Yeah. Just a different way to write it. Because it lets you do that in that. Okay, so let's do this one. So the problem will look like this. So it'll say given that p of x equals x to the fifth minus 3x to the fourth minus 28x cubed plus 5x plus 20. We want to find, or it'll say what is p negative 4. First thing, yep, David?
You said the add versus split.
Yes, good. First thing you want to do, kind of answer my question for me, is go through here and look, make sure it's in standard form, and check if you're missing anything. And as David said, we are missing that 0x squared term. So when you do synthetic or when you do long division, you always have to have those placeholders in there. So instead of having to set this equal to 0, you just plug it into the elbow as is. Answer your question. So it's just negative 4 is in here. It's like they already solved it. Okay? So in the elbow, we have the negative 4. Tell me what's right here. 1, negative 3, negative 28, 0, 5, 20. Perfect. Make sure you check for those missing pieces before you start a problem. Because I've already told you, I guarantee you, I'm going to put one with a missing piece on your test. And if you try it without inserting a 0, the placeholder, it just goes really wrong. Not fun. Okay.
What do you mean you use the x cubed to
Yeah, I just check. I go down in order, right? I have the 5, I have the 4, I have the 3, I'm missing the 2, so that's where I have to put that placeholder in.
Okay, so what if you're looking for the 4? You can
Yep. Whatever I'm missing, I have to put in. Okay, first step, bring the 1 down. Negative 4 times 1, negative 4. Negative 3 minus 4, negative 7. Negative 4 times negative 7, positive 28. So if you're sitting there in a test, this is where you start to get a little freaked out, right? Because you're like, oh crap, stuff's canceling, this is not good. But it still works out, so don't freak out. You have negative 4 times 0, which is 0. 0 plus 0, still 0. Negative 4 times 0, still 0. Now we get a number back in play. 5 plus 0 is 5. And then negative 4 times 5, negative 20. So given that fantastic definition of remainder theorem, do I have one? No.
So the last one will be always
Either 0 or any number. It could be anything really.
And you'll always try it in the...
Yep. I think it's just good because if we write this whole string of numbers, it gets confusing, like where the remainder is, so I like doing that in reverse just so you can see it. So you don't have to write this as an answer, but I just wanted to show you what it looks like. We started at x to the 4th, we're dividing it by x, so where does this start? I said x to the 4th, didn't I? And then x to the 5th. So this starts at x to the 4th, minus 7x cubed. This would be plus 0x squared plus 0x plus 5. So if I were to write this dividing it, it would just be x to the 4th minus 7x cubed plus 5. all I care, I just wanted to show you what happens there. All I care about is that. Yep, yep,
So when it says,
yep.
when it says, you put a number, then.
All I care about is right here. Like when I grade your test, I'll look right here, if it's the same number, then I go, thank God. I don't have to go through and figure out what went wrong in here, because it gets confusing in the grade 94 of these things. All right, ready?
How did you
Come in,
define
Greg.
those 5 in the second last column from 0 and -4?
From 0, so -4 times 0 is 0. 5 plus 0 is 5. Right, we're adding and subtracting up here. We're not multiplying. So -4 times 0 is 0. 5 plus 0 is 5. Okay, so you're still looking at me like you're confused. Griffin?
So your answer isn't the 1x, yeah, isn't the x to the fourth one, it's the next few.
No. All I care about is this.
Okay. And do you have to put p, a, and 0, or?
Man, really good. You know. All right, so your homework is on the board there, page 308. It's another 5-4, 308, 21 through 39, plus 40.